Hey guys, good evening everyone. Welcome or welcome back again to another video tutorial lesson from the AP3X Institute of Mathematics Education. My name is Akin, your math instructor. And in today's video, in this particular upload, this is the fourth upload from this exam paper that I had structured for my students that are currently preparing for exams coming up in May. This practice paper here had some very interesting questions that I recommend, or it was recommended to me that I do and provide to my students for a form of revision. All right, so I'm just going to be going through questions 5 and 6 in this particular tutorial here, and of course the diagram seen above here will be a separate diagram that I'll do in my circuitarium complete guide. I won't be doing this particular question in these series of videos. This will be a question attached to my circuitarium playlist of videos. All right, so here we go. We're going to wrap this exam paper up. Of course, if this is the first time here on the channel, consider smashing that subscribe button below, leaving a like, and leaving your comments, video requests, and suggestions down in the comment section below. And leave a like if it is that you're getting any sort of value from this particular tutorial. Okay, so here we go. So question 5 here says that we are given that the points P has coordinates -4, -1, and T has coordinates 2, 5. We are to determine for the line PT its gradient and midpoint. I think I have enough space to do it right here. So we need a gradient formula. Gradient formula, symbol for gradient is M, and so we know M is equal to y2 minus y1 divided by x2 minus x1. All right, we leave our points x1, y1, and we leave our next coordinate value point here, x2, y2. Plug those numbers in. Y2 is 5. Take away y1 is -1, so that's 5. Take away -1 divided by x2 is 2. Take away x1 is -4. This seems to be a really nice gradient here. 5 negative times negative is positive. 5 plus 1 is 6. 2 negative times negative is positive. 2 plus 4 is 6. So we end up with a really nice gradient here of 1. All right, so our gradient value here is 1. All right, really nice. Easy. 2 marks here. Let's move right along now to getting the midpoint of this line. Midpoint formula is x1 plus x2 divided by 2, and that is going to be y1 plus y2 over 2. Please note that these formulas are not provided on the CSEC exams, so it's imperative that you get those formulas in the cranium stored somewhere. All right, so again, let's go right in and add our points or ordinate values. -1 plus 2, so that's -4 plus 2 divided by 2, comma, y1 here, which is -1, plus y2 here, which is 5, divided by 2. All right, so we end up here with -4 plus 2, which is -2 divided by 2, and we have -1 plus 5, which is 4 divided by 2. This works out nicely to be that -2 divided by 2 is -1, and 4 divided by 2 is 2. All right, and that is the coordinate values of the midpoint of the line PT. All right, so this of course is a video. I already have a video on my channel that goes through the entire series related to coordinate geometry. I also have some really interesting structured questions, twists and turns in the questions, any ways that CSEC could perhaps structure the question. I have tutorials on that, so do check out that. The link will be provided in the description box below. All right, now we're going to be looking at finding the distance between the point P and T. So we're looking for the length formula here. All right, so length formula here again is the Pythagorean theorem extended. So that is x1 plus x2 squared, or no, pardon me, it is x1 minus x, so it's, pardon me, it's x2 get my formulas confused, guys. Minus x1 squared plus y1 plus y2, or y1 or y2, pardon me. I think I'm getting a little confused here, guys. So that's y2 minus y1 here, all squared. All right, so that's what we're working with here. All right, tends to get a little confusing for some students. Where should I put the minus or the plus? But the minus is always the sum between the coordinate values here, and the difference between the upper ordinate value and the lower ordinate value. Okay, so here we go. I'm gonna plug those in. We already have our points established from the very first question. So we have here, we're gonna have here 2 take away -4, and that's going to be squared, and that's going to be plus 5 take away -1 squared. All right, so that's going to be length is equal to the square root of 6 squared plus 6 squared. All right, and that's going to be equal to the square root of 36 plus 36. Length is equal to square root of 72. You can write this in terms of units. Use your calculator to find the square root of 72. At times, CSEC will ask you to express it in surd form. This question didn't ask for surds, but in the event that you wanted to express this, perhaps say in surds, then you'd have the square root of 36 multiplied by the square root of 2, which would have been here, say 6 root 2. All right, that's in the event that CSEC asks to write the answer in this particular form here. All right, I don't have a video here on how to simplify surds or radicals, but in the event that you need to know what I just did here, hit me up in the comment section. I'll try to make a tutorial for you there. Okay, all right, so that takes care of that answer there. All right, so we're expecting the answer to be about 8 point some change. Okay, the equation of PT. All right, so we know that the equation of a line is equal to, or implies that y is equal to mx plus c. I'm looking for the equation of PT, so we would have already had the gradient of PT, which we had worked out here to be 1. So m here would have been equal to 1 already, and we would have had an x coordinate ordinate value and a y ordinate value. We could have used either -4 -1 or 2 5. I think I'm just going to use the 2 5 because it's positive. It's a lot easier to manipulate. But if you want to use the -4 -1 as your x and y, then by all means that will get you to the same result. Now here we have y2 being equal to 5, so that's 5 is equal to m is 1 multiplied by x is 2, and we're looking for c. All right, 5 is equal to 2 plus c. So to isolate c, we end up with c being equal to 5 take 2. We would have just transposed the 2 over here, right? So 5 take 2, so c is equal to 3. So therefore the equation of my line here is y equal x 1x plus 3, and that's the equation of the line. All right, beautiful. That's how we get that done. All right, now if you're interested in using the formula that I had indicated in one of my previous tutorial, where I showed you how to improvise by using the formula y minus y1 equal m times x minus x1, some of you guys may think that it's a little bit harder, but this is a formula, a transpose formula, that avoids or prevents you from actually calculating the value of c. C is automatically calculated within this formula. So check that tutorial out of how to use that formula. If not, by all means, use the traditional method of finding c and rewriting it in the form y equal mx plus c. All right, so moving on to the last question here for 3 marks. So far we would have copped up here 8 marks. Let's just wrap this up by finding the equation of the line that is perpendicular, or find the equation of the perpendicular bisector, all right, of PT. Find the equation of the line perpendicular bisector, or the perpendicular line bisector of PT. All right, so a couple of hints here. Perpendicular implies that the original gradient will now be converted to a negative reciprocal. So we had calculated m1 to be equal to 1, So therefore, using a shortcut method, m2 here, which is the perpendicular gradient, would have been the negative reciprocal of 1. If you reciprocate 1, you're still going to get 1, but the negative reciprocal makes m2 minus 1. Again, if you want to prove this, you can use the formula m1 times m2 equal minus 1. And so therefore, m2 would have been the subject of the formula to which you're searching for by implementing 1 here, or by implementing 1 for your gradient here times m2, that's equal to minus 1. Then divide both sides by 1, you will end up with m2 being equal to minus 1 divided by 1, which would have been equal to minus 1. Hence why I can almost say that m2 is minus 1 without calculation. Alright, very good. So now we have the perpendicular gradient, and it says here bisector. Now bisector implies that the line is actually passing through its midpoint. So we would have already calculated the midpoint from in the second question here. That's this part, minus 1, 2. So we're going to use those two values as our x and our y ordinate value. All right, so in the formula here again, y equal mx plus c, you're going to find that the y here is being represented by 2 because that is the y ordinate value of your midpoint or the bisector point. So that's 2 is equal to, we just calculated m2 to be minus 1 multiplied by x here is being represented by minus 1. And so you're going to find here that this is going to be added to c. All right, so here minus 1 times minus 1 is going to be positive 1. So that's 2 is equal to 1 plus c. If we transpose here, we get 2 take away 1 is equal to c. Therefore, we find that c is equal to 1. All right, so our equation formula for the perpendicular bisector is y is equal to minus x or minus 1x plus 1. All right, and that is the equation of our perpendicular bisector. All right, so hopefully you guys catch on to that. That was a really nice, well constructed question. Nice 11 marks. Definitely, if it is that you're unfamiliar with what has been shown to you in this video, then a link will be provided in the description box below. You can take a look at my tutorials, complete tutorial guide on the whole concept of coordinate geometry from beginning to end. All right, now we're going to be running through these particular questions down here that's related to algebra, and so we're going to have a look at all of those right now, guys. So just a moment, we'll be right back. All right, guys, so we are back and we're going to have a look at question 6 here, which is the final part of this particular upload. And in this section of the video, we're going to be looking at transposition, and we are going to be looking at solving a very basic linear equation along with factorization of difference of two squares and quadratic expression. All right, I know that you guys had requested a video on my channel about transposition. That video is currently being done, so as soon as I'm finished, I'll get that uploaded for you. I've already put a video on my channel with how to solve linear equations, so you can check the playlist below or check the link in the description. You can learn how to solve questions like these within a quick succession. All right, so here we are asked to make R the subject of the formula, or make R the subject of the formula in each of the formulae that we have here. Okay, so the first formulae that we have is R minus H is equal to RH, and the objective here is to isolate the R. Now, one of the problems that I find that my students have is that they believe or they assume that these two R's are separate. I did find that one of my students, what they did is actually divided both sides by R, and they cancelled the R, which is legal. It is legal to do that. So you end up with H being equal to R minus H over H. And they made the assumption that this would have been correct. But what makes this mathematically incorrect is that if it is that you're making something the subject, pardon me, I believe that they're not divided by R. Pardon me, guys. They divided by H. So they ended up with R being equal to R minus H over H. That's what they did. Now, here's the problem, the mathematical problem with this. You're making R the subject, but R is in your answer. Once the subject or the intended subject is isolated, then it should not be in your answer. This is what makes it mathematically incorrect. So what you needed to do here was that you needed to transpose like terms. We needed to group the R's together, right? So here we're just going to be transposing the RH, and we're going to end up with R take away RH is equal to, we're going to transpose the minus H, we're going to get positive H. Right, now the R's are together. Be careful now, you are not allowed to subtract because these are two unlike terms. So what we do here to isolate the R, we factorize the R, or factor out the R. Factor out R divides into R, we end up with 1. And R divides into RH, the two R's will cancel, leaving us with H here, and that's equal to H. Now it's very easy now to isolate R, because we have to only just basically divide both sides here by 1 minus H, and then you're gonna find here that H divided by 1 minus H. So therefore 1 minus H cancel 1 minus H on the left, so R is now isolated. Answer is H divided by 1 minus H. Alright, and then you can see here that R is isolated and R is not in the answer, hence this is mathematically correct. Alright, so hopefully you guys catch on to that little question there, valued 2 marks. Let's look at another one here. V is equal to pi R square H. Most of you guys would have been familiar with this formula, which is the volume of a cylindrical prism. Right, that's the formula for that prism, the prism that looks like this. Right, so we're going to transpose that formula here to make R, which we would have known that R is the radius of the cross section of the cylindrical prism. But anyways, we're not looking at using the formula, we're just rearranging the formula to make R the subject. Now naturally here you'll realize that we can isolate R, or well, R squared almost immediately by simply dividing both sides by pi H. So if we say here pi R squared H divided by pi H, you will find here that the pi cancels the pi and the H cancels the H. So therefore you would have ended up here with R squared, or V divided by pi H, is equal to R squared. Now to get rid of the power attached to the R, then we simply say the square root of R squared is equal to the square root of V divided by pi H. Square root cancels square, so R is equal to the root of V divided by pi H. Alright, and that there is our final result. Alright, so that is how you would actually do that question. Alright, so hopefully you guys catch on to that particular question. Alright, we're gonna wrap this up. I'm just gonna clear the screen here. Make sure that you guys are working with me, in fact, and you're getting the same results as I am getting. Alright, and if you haven't subscribed or hit the like button, go ahead and do so right now, so we can get those videos out to more CSEC students who need a lot more help. Here we go. We have 2 open bracket p plus 5 minus 7 is equal to 4p. So here we can distribute. 2 times p is 2p, plus 2 times 5 is 10, take away 7 is equal to 4p. Alright, so we have 2p, 10 take away 7 is 3. We are allowed to subtract those because they are like variables or like terms. So here we need to get the p's on one side. We have a choice. We can transpose the 4 to the left, or the 4p to the left, or we can transpose the 2p to the right. I kind of like transposing the 2p to the right because I always prefer to transpose in the direction of the variable with the largest coefficient. So I'm just going to leave my 3 here, and I'm going to end up with 4p take away 2p. Transpose, change signs. So 3 is equal to 2p. And if we divide both sides by 2, you're going to find here that p works out to be 3 over 2. Alright? And that is how you work out that particular question. All right, so that was pretty quick, pretty easy, nothing too tough. Check the link down in the description box below and let me know in the comment section if it is that you are getting the same answers as I am getting. All right, so we have here last two questions: factorization of a difference of two squares. All right, so the rules for this, I don't have a video out on factorization as yet, but I do have a video out on quadratic expressions, but not any on difference of two squares. I'll be doing one of those soon and very soon. All right, so this may be new to some of you guys who are watching for the first time, as well as this may be something quite familiar with some of my students. All right, so here we need to factorize this expression here. That's 25m squared take away 1. The first thing that I need to do here is to ensure that all my variables are expressed to a power of 2. So I could change 25 here to being 5 squared. My m is already squared, so my m is already squared, and 1 squared gives 1. All right, and the rules when it comes to this is that we open two pairs of parentheses and we're going to be inserting, say here, a plus in one in either and a minus in the other, and then we simply spread or distribute the variables in the equation, the terms, evenly across the brackets. So we have 5 here and 5 here, we have a m here and a m here, and we have a 1 here and a, let's say here, that a 1 here, and that's my answer: 5m plus 1 and 5m minus 1. If you go ahead and do the product of two binomial expressions, and you can go ahead and say here 5m plus 1 by 5m minus 1, and you'd use the bird beak technique, that's the distribution here, you'll find that your answer simplifies down to 25m squared take away 1. So you can definitely go ahead and try that. Okay, all right, and that is it for that question. Let's look at the final one here. I have a full tutorial video out on this particular question that explains all the steps when it comes to factoring a quadratic expression. All right, so these questions are from an exam paper. I'll just be running through the steps. But if you really want to master the ability, I have 2 videos out on this. Check those out. A link will be provided in the description box below. All right, so the first step here is to go and say here 3 times 15. That's equal to 45. I need pairs of factors of 45 that could possibly give me 12. I think I already have it. That's 3 and 15. Making the 15 positive and the 3 negative. You're going to find that 15 take away 3 is 12, and negative 3 times 15 here is negative 45. So my 2 factors are going to be minus 3 and positive 15. So I end up with 3n squared, or is that n? Yes, that's n. So 3n squared minus 3n plus 12, pardon me, plus 15n. These are the 2 terms I'm putting in the middle, minus 15. Factorized by grouping, you find out that 3n is the common factor here. 3n divides into 3n squared goes n times, minus 3n into 3n goes 1. Common factor on the right side here is positive 15. 15 divides into 15, n leaves n. 15 divides into 15 goes minus 1. So therefore my final result here is 3n plus 15 and n minus 1. This is even not completed as yet. All right, because I could still factor out here 3. So 3 open bracket n plus 3 by n minus 1. That would be the complete factorized expression here. All right, and the reason why we have an answer looking like this is because in the initial stage of the question, the whole entire expression could have been divided by 3 to simplify the working out easier. But here's what we have. We have simply here 3 open bracket n plus 3 by n minus 1. All right, and that is it. Beautiful question. All right, so hopefully this particular tutorial was able to give you some assistance. Please like, share, and subscribe. Leave your comments, video requests, and suggestions down in the comment section below. Leave a like and share this out to your math groups and math community. We'll see you next time in another tutorial video. Take care. Bye bye.